In this demonstration, we're going to discuss how to configure uninterruptible power supplies, or UPSs. Using a UPS is a really good idea, especially for sensitive systems. It maintains AC power to the battery in case of a power outage. This gives you time to bring your system down cleanly. Remember, Windows doesn't like unclean shutdowns. They can corrupt and discard data. Before we talk about how to configure a UPS, we need to bring up one key mistake that a lot of users make. People often plug their system's AC cable into a protected outlet on the UPS, but they don't ever connect the management cable. Most UPS systems have a USB cable that you can plug into your PC system, which allows communications between the UPS and the computer's operating system. Using this cable, the operating system can monitor the battery's charge. In return, the UPS can send commands to the operating system to shut down. For example, if a power outage happens, the UPS can send a command to the operating system saying, "We need to shut down because my batteries are going to run out in 5 minutes." If you don't connect the management cable, there's a chance that the UPS's battery capacity will be shorter than the duration of a power outage. So, how do we set the system up? First, we plug the UPS system into a wall outlet. When you initially purchase a UPS, the battery will probably need to be charged for quite some time, maybe even overnight, before it reaches 100%. Okay, so now I plug my PC into one of the protected outlets on the UPS. Be very careful with this because you'll often find that only some outlets are battery backed, and others only provide surge protection. If you plug your PC into a surge-only outlet, you won't have any battery backup. All right, next we need to plug in the serial or USB cable from the UPS to the PC system and install the management software. I've already done both of those things. As you can see, I have UPS software installed and running on my Windows PC. The actual software you use will depend upon which UPS you've purchased. The APC company provides a popular UPS system that uses PowerShoot software. That's what we're using here. When we start the PowerShoot application, the Monitor Your System tab is displayed by default. Here we can view a summary of historical power events that have occurred, and we can also view battery backup status information. We can see that electrical power is currently supplied by the AC utility power. In other words, this system is running on AC power from the wall outlet. Right now, it's not running on battery. The battery here is 100% charged. We haven't had a power outage, and we haven't had to switch to battery power recently, so no historical battery events are recorded. And here we see that the input voltage coming in from the wall outlet is 120 volts. Now we know that the UPS is functioning properly, we're all hooked up, and everything's ready to handle a power event. Now it's time to make some configuration changes. Let's go down to Options. One of the things we can do is click Enable PowerShoot Notification Sounds. A lot of people turn this function off because when the power goes down, it makes a really annoying sound. In my opinion, though, it's a good idea to have this enabled. It gives you audible notifications that the system is running on battery power. Let's go to Runtime Configuration. This is probably one of the most important configuration screens. We have two different options here: preserve battery power and keep my computer running as long as possible. This one basically says that if a power outage occurs, it should run on battery until it's down to about 5 minutes left in the battery capacity. At that point, initiate the shutdown. It's set to 5 minutes because sometimes it takes a few minutes for a computer to shut all the way down. We want to make sure that there's plenty of time for the shutdown to occur because there's no point in having a UPS if it runs out of battery in the middle of the shutdown process. You're almost guaranteed to end up with corrupted files somewhere if that happens. The option I like better, though, is preserve battery power. Instead of keeping a system running as long as possible, with this option we're saying, just please shut down this computer after it's been on battery backup for a very short amount of time. In this case, it's set to 5 minutes. So if we have a power event and the power doesn't come back on within 5 minutes, this computer system is going to shut down automatically. I prefer this option because sometimes, like during a storm, the power goes off and on several times and the battery starts to drain. I like to wait until the power event is pretty much over so that my system doesn't go back and forth between battery and normal power. If you use the first option, you might not have enough battery power left in the UPS to shut the system down cleanly. If you use the second option, on the other hand, you'll still have plenty of battery power left for whatever you need to do. As you can see down here, my estimated battery time is 343 minutes. Let's go ahead and click Apply. Next, let's go to our notifications. Here we can configure our battery backup alarms. The option we configured earlier was the PowerShoot notification sounds, meaning that Windows itself is going to pop up a notification and generate a sound to let us know the system is on battery power. Here, we're configuring the backup battery unit itself. If you've ever had the power go off and heard the horrible beeping sound that the UPS makes, you know how loud it can be. We have several different options. We can enable the backup battery alarm at all times, or we can disable it. That's probably not the best idea because you want to know if the power has gone off and that your system is now running on backup battery. Here's the enable option. I don't like this option because it could kick off in the middle of the night when I don't really care. So the default option is the better one. Basically, it enables the backup battery alarm during the workday. So we're going to let the UPS shut down the operating system cleanly. We'll leave that set to its default value. Let's go down to sensitivity. This is where we specify the circumstances when we want the UPS to kick in. Remember that your UPS not only protects your system from power loss, but also from electrical noise. So if the UPS detects enough electrical noise on the input power coming from the utility company, it can shut that off and use battery power in order to protect your equipment. That's a good thing. We have 3 different sensitivity levels. Low causes the system to switch to battery power less frequently, but it could, as it notes here, allow greater voltage distortions to reach your computer, which could potentially damage your equipment. Medium is a good setting because it switches the system to battery power when moderate amounts of voltage distortions hit the computer. If you want maximum protection against electrical noise, you can select high. Be warned, though, that almost all utility companies have a certain degree of voltage distortion coming in through the AC power line. Depending on the company, the high setting could cause the system to use the battery constantly. That's why medium is selected by default, and my experience has been that this is just about right. We'll leave it at the default value of medium. Now, let's come down here and select voltage. In this screen, we essentially define what a power event is. We specify a high and low voltage threshold. Normal utility voltage is between 115 and 120 volts. If the AC utility voltage goes above 139 volts, we're going to go on battery because we're assuming that some kind of spike is coming down the line, and we don't want that. If the voltage drops below a certain value, in this case 92 volts, we're going to assume that we're dealing with a brownout of some kind. Once again, we want to go on battery. I usually leave these set to the default settings, but you can adjust them. Down here you can see what the current power source is. We're running on AC utility power, and the estimated battery time is 343 minutes. Now, this brings up a really important point. This estimated battery time assumes that there is one PC connected to this UPS. Oftentimes, people plug multiple systems into one UPS, and that drains your batteries faster than this estimate. My advice is to never connect multiple PCs to the same UPS. I know the temptation is there, but I'd recommend that you implement one UPS for each PC system to get the full estimated battery time. A lot of PC techs like to connect other devices to the UPS as well to keep them up and running. That's okay as long as the devices don't draw too much power. For example, I know a lot of system techs that work with small businesses, and they connect the organization's switch to the UPS so that networking remains enabled during the power event. That's always a good idea. In addition, they connect their internet equipment, like their router or cable modem. Again, that's not a bad idea. It keeps all your network connectivity up and running in a power event. And because the switch and the cable modem don't really draw much power, it doesn't affect the estimated battery time very much. There's an ongoing debate as to whether you should plug your monitor into your UPS as well. You can. In fact, I usually do. But just be aware that it cuts down the estimated battery time because monitors do draw a lot of power, although it's not as big a deal today with LED and LCD monitors. The one thing that you should never connect to a protected power outlet on your UPS is a printer, especially a laser printer. That's because laser printers have heating elements that consume a huge amount of electricity, and they'll drain the UPS battery very fast. That's it for this demonstration on UPS settings. In this demo, we talked about implementing and configuring a UPS for power events.